Hi, today's session is on replacement problem, and in this session we'll be discussing first model of replacement theory. So model 1 talks about model 1 is for those items whose running cost increases with time and value of money remains constant during the period, right? We'll see a problem and we'll try to find it out, the relation with model 1 and the problem, right? So the problem says a manufacturing firm has come to know from his records that a machine costing rupees 56,000 is not working satisfactorily in spite of its regular maintenance. With a view to replace this machine, the following facts were. We have been given three values, three different informations rather. Year, which is from 1, 2, 3, 4, 5, 6, 7, and 8. Operating cost. For each year, the operating cost has been mentioned. First year, the cost is 7,000. Second year, it is 9,100. Third year, it is 11,900. Likewise, it is increasing, and eighth year, it is 42,000. Next column is resale value. That means if machine is sold to someone, right? In that case, if it is sold on first year, uh, 28,000 can be received. On second year, 14,000 can be received. On third year, 8,400. Likewise, gradually it is decreasing, and on eighth year, it can be sold only for rupees 3,000. Now let us try to see what we are supposed to do in this. We have been asked to advise when should the machine be replaced, right? Now, first of all, we need to understand why a machine need to be replaced. See, first of all, it is a physical entity, so it should have a life, right? After that, it may stop working. Now, replacement is required because, see, every year the operating cost is increasing gradually and resale value is decreasing gradually. So we need to identify a year where the replacement decision should be taken so that cost, resale value, everything can be taken care of. Now, as we said that we'll try to see the relation between the problem and model one. See, the model one says for items whose running cost increases with time. So this is your running cost. Your operating cost is your running cost. Sometimes it is also known as maintenance cost. So it is increasing with the year, and value of money remains constant during the period. Nowhere it has been mentioned that your value of money is changing with this rate. So we are considering the value of money is same in first year as well as in eighth year. So during the course of time, the value of money has not been changed. Right? Now, being a manager, you need to answer to your top management when the machine need a replacement, and that has to be an optimum decision, right? So let's come here. You need not to make any changes in your year column, so let it be like this only. Operating cost, the operating cost is symbolically written as F. So this is your F column. Resale value, symbolically it is written as S. Now, a column has to be added which should be named as depreciation. Depreciation, right? And we are writing the formula how to get depreciation. Depreciation equals to, I'm sorry, let us not get into depreciation first. We will calculate depreciation, but before depreciation, we need to have another column which is called cost. and it should be written as C. Now, how to get a cost? Go back to the uh, initial problem. It mentions that his record that a machine costing rupees 56,000. That means whenever in the year between 1 to 8 you are purchasing 56,000, you are purchasing this machine, you are spending 56,000. That's the cost of the machine. So whether it is first year or second, third, fourth, whichever year it is, right, you are spending 56,000 to purchase this machine, right? So that is why cost column has to be filled with 56,000. I'm just dragging it down to solve 56,000, right? So what I did is, from the given problem, I found out the cost of the machine, right? For many questions, the cost of the machine may vary with the year, right? That means in first year the cost may be something else, in second year it may change, in third year it may change again, and likewise it will move. For our problem it is not changing, so it is 56,000 only. Next column you have to add, that is depreciation. And depreciation should be written as C minus S. That means cost minus your resale value. So let us go to rapid depreciation, right? So this is your C and this is your resale value S. So we are subtracting it, cost minus resale. So this is our depreciation. And I'm dragging this. So for every this thing I have got depreciation value. How we calculated this? C minus S. That means cost minus resale value. Next, we have to calculate something called cumulative operating cost. And it should be written as sigma. Let me add sigma in this. Go to insert symbols. Sigma. This is our sigma. So sigma F. Adjusting it, wrap text. So this is communication. Take. Now, what is sigma F? For first value, it is 7,000 only. For second value, you have to get summation of these two. So it is 16,100, right? For this, you have to get summation of these three. So it should be 61 and 917 and 11. So it is 28,000. So what I'm doing is I'm just adding it up. This plus this plus this. Likewise, it will move down. So what we did, we got the cumulative operating cost for each year, right? That means first year you had spent 7,000. Second year you have totally spent 7,000 plus 9,100, so 16,100 you have totally paid, right? Now you have to come for total cost. Total cost, which is your TC equals to depreciation plus sigma F. right? Copy this sigma f. We are putting it here. Sigma f. Fine, I'll just drag it and wrap text. Just a little more, yes. So now the total cost, how to get total cost? This is your depreciation plus your cumulative OC. So let us add depreciation plus cumulative operating cost and add this down, right? So for every year, we have got the total cost down. Now the last column will add as average cost. Average cost is denoted by AC. AC equals to TC by N, where N is number of years, right? So, see in this case, this is your total cost and this is your number of year. That means in first year, you have 35,000 total cost. What we are supposed to do, we are supposed to divide total cost by the number of years. So divide this. Similarly, total cost divided by number of years. Divide this. Total cost divided by number of years. So this is divided. So finally, I'm dragging it down. So this is our average cost. Fine. Now find it out the least value in the average cost. So start taking from the top 35,000, 29,000, 25,000, 23,800, 23,240, and then it started increasing. So this is our least value, right? And this least value is for which year? It is for 5th year. So we'll write over here the machine. Should I go down? The machine should be replaced at the end of 5th year as the average cost is the least in this year, right? So see the important costs which we need to know to solve this kind of problem. First, you need to have an operating cost. Sometimes operating cost is also known as running cost, maintenance cost, etc. Resale value. Resale value is sometimes also known as salvage value, scrap value. In these words, we pick up this category of cost. Then you need to know the cost of the machine. So cost of the machine you can identify, right? Once you have these three, then only you can go for depreciation, which is cost minus resale value. You need to go for cumulative operating cost, and then total cost is the summation of depreciation plus cumulative value. Finally, you have to calculate average cost, and which is defined as total cost by number of years. So every total cost should be divided by respective number of years to get average cost. And once you get average cost, look for the least value, and that will indicate the year in which machine should be replaced. Hope you have understood. In the same context, we'll try to attempt one more practical problem, right? Where a little more information with different dimension has been given, right? It also talks about model 1. That means the running cost or the operating cost will increase with year and value of money remains constant during the period, right? So the problem says a firm has a machine which is to be replaced as it wears out. a new machine is to be installed now and an optimal replacement plan is to be for next 7 years, after which the machine is no longer required, right? That means if you can replace within 7 years, it's good. Otherwise, it doesn't require after 7 years. So what we need to do is we need to suggest a replacement policy within 7 years old. Following data are given. Let us see the data. It has given year from 1 to 7. Cost of new machine, right? See, every year the cost of machine is getting changed, right? We know the cost of machine is symbolized as capital C. So this is our C, right? Salvage value. Salvage value is nothing but the resale value, right? So resale value, we used to write it as S. Operating cost is our annual maintenance cost or annual running cost rather. So this we symbolized as F. Now see, we have all the three costs. So the first thing is to get depreciation. And we know depreciation is defined as C minus S. So this is RC minus, this is our resale value, right? The same thing, C minus our resale value. Now I'll just drag it down, so I'm getting my depreciation column ready, right? Next, what we are supposed to do, we were supposed to find it out cumulative operating cost. That means sigma F, right? So sigma F, right? How to get this? For the first operating cost, it remains same, but for the second onwards, it is the summation of the earlier costs, right? So 2,500 plus 3,000, that means this plus this. Next, for the third case, it is the summation of all the three. So this plus this. So I'm dragging it down. Now we have got our cumulative operating cost column ready. Now once we have our depreciation column, this has to be capital S. Depreciation column and cumulative operating cost column, we can always go for our total cost. So total cost TC equals to depreciation plus sigma F plus sigma F, right? So total cost depreciation plus sigma F. Depreciation plus sigma F. So I'm just dragging it down. So this is my total cost. Now the final column will come as average cost AC equals to TC divided by number of year. So AC, this is our total cost divided by number of year. Now this is our total cost, which is divided by number of year. This is our total cost and it is divided by number of year, right? So finally I'm dragging it down. So this is our average cost. Now look out the least value in this average cost: 5,000, 4,750, 4,583.33. And after this, all the values are increasing. So this is our least value, right? This is our least value. For this, the corresponding year is third. That means the machine should be replaced at the end of third year as the average cost in the third year is right. So let us try to summarize. See how to check the problems whether it is belonging to model 1 or not. First, the operating cost or the running cost or the annual maintenance cost should be in increasing order with year, right? Secondly, there will not be any information on the discounting of money value. That means time value of money will not be given to you. So once you identify this is for model 1, you need to look for four important things rather. You need to have years, you need to have cost of machine, that is C, you need to have salvage value or resale value or scrap value, that is S. Finally, you need to have operating cost, running cost, maintenance cost uh, as F. Once you have these four things, go for your depreciation. How to calculate depreciation? For each year, cost minus resale value, salvage value, right? So you will get it. Then you have to go for cumulative operating cost. Whatever operating cost you have been given, you have to take the cumulative of this. Once you get cumulative operating cost, you need to go for total cost. And total cost is defined as depreciation plus cumulative cost. Finally, average cost you can get by dividing total cost by number of year. Once you get your average cost, look for the least value in average cost and the corresponding year. That year will be the replacement year. Hope you have understood the concept. For any further query, you can contact me on arc.srkr86@gmail.com. Thank you.